Hello. This video is going to give you an introduction to the project that you're going to create around linear regression. So you can see over here I've kind of given a few of the key terms that you're going to need to complete here in order to complete this project. I've already started out with some data that I've gotten from somewhere. You are going to need to collect your own data, whether that is physically, and if you do so that way, then you need to explain how you collected your data. Or if you go online to collect your data, that's fine too. If you do that, just cite your data, so cite your references, excuse me. So this is where I found my data, was at baseballreference.com. So I've got my data input here, and I chose this data because I think they might be related. I think the number of home runs a team hits might tell us something about how many runs that team is also going to score. Okay. In your project, you're going to have to do that. You're going to have to find a set of data that you believe is connected somehow. Then you're going to also complete another part of the project where you try to find two pieces of data that you don't believe are connected at all. Okay. So let's start with this one here. I've got my data, and one of the things I'm going to need to do is to create a scatter plot of this data. And on Excel or Google Sheets, the easiest way to do this is just you're going to highlight. So to highlight, you left click, hold it down, and just move your mouse over everything that you want highlighted. Okay. Another way that you can do that is to click in a cell, hold the shift key down, and then use your arrows. And what you can do from this point is you can push end. You're still holding the shift key, push end down, and it will take you to the bottom of that list. Okay. So you want to highlight that list, and then you want to create a scatter plot. So to create a scatter plot, we're going to go up here to Insert, and we're going to scroll over to this one right here where it says Insert Scatter XY or Bubble Chart. Okay, and click that, and then we're just going to click this top one here. Okay. And you can see here's my data. Now you may want to play around with this. Notice we've got a lot of empty space here. If you right click the axis, you can format the axis. Okay. So maybe instead of having it start at 0, maybe I want it to start a little bit higher, start at 100. Okay. So my minimum bound might be 100 over here. Okay. And now you can see the data has spread out a little bit. Maybe I want to change my bounds over here. Looks like there's nothing below 500, so maybe I want my minimum to be 500. Okay, so I type 500 in the minimum, and then if I just click on my graph, now the data seems to be taking up a bigger portion of my graph. And that's important when you're creating a graph, is you want your data to take up a good portion of your graph, and you don't want a lot of white area. I'm just going to click the X here to close out of that, and here's my scatter plot. Okay, so that's the first step in the process, is to create a scatter plot. The next step then is to talk about these four things. Now all of these terms, you'll find other videos describing these terms. This video is just for the project here and as an example. So for the form of this, I would say that that looks fairly linear. Okay, we can tell that there does seem to be some sort of relationship. It does appear to be linear. It doesn't appear to be curved. So the form would be linear. The direction, well, it seems to be going up in a positive direction. So our direction would be positive. The strength. The closer all of these points lie to being on the same line, the stronger the relationship. So this isn't a strong relationship, but it appears to be at least a moderate relationship. There appears to be, some positive linear relationship between these two variables. And then are there any outliers? Probably not. We might want to investigate this point down here as a possible outlier, but it's probably not an outlier. It's probably going to be more obvious than that if you do have an outlier. So those are the four things that you're going to want to talk about there. This all needs to be included in your paper or your presentation, however you decide to present this, whether it's in a PowerPoint or you write a paper or you make a video. Those four things need to be discussed. Okay. You also need to discuss R. So what is R? Well, the easiest way to get R on here is going to be to right-click on one of your points and then add a trend line. Okay. When you add a trend line, we already said we think it's linear, so we want to make sure that the linear bubble is checked. But then if we scroll down, we can see that it asks us if we want to display an equation on the chart, so let's click that. And if we want to display an R² value on the chart, so let's click that too. And now we can close that box, and you'll notice we've got some numbers here kind of in the middle of our screen. Let's just grab those. So hover over the numbers and then click and drag them up. And we can see it's given us an equation, it's given us an R² value. Now the R² value, it is the square of R, and so if we want to find out what R is, we can just type in a little formula here, equals SQRT for square root of our number. Our number is 0.2964, and then we close the parentheses, we hit enter, and it tells us that R is 0.544 about. Remember that in order for it to be a strong relationship, we're talking about R values 0.7, 0.8, 0.9, and so on. A weak relationship would be closer to 0. This is an R value of about 0.5, so that's a fairly moderate strength relationship. So R talks about the strength of the relationship, in this case 0.5, moderate strength. Okay. The next thing is our equation. We've got that right here. So the nice thing about Excel or Google Sheets is it's really easy to get an equation in there. Once we have that equation, we also want to talk about the slope and the y-intercept in the context of our data here. So in this case, my slope is 1.2823. What that tells us is that for every home run, we expect runs to increase by approximately 1.28. Okay. So for every home run that a team hits, we expect the number of runs they score on average to increase by about 1.28. And then what does the y-intercept mean? Well, the y-intercept in this case is 491.78. Well, the y-intercept, that's when our x value is 0. Our x value in this case is home runs. So we're saying if a team hits 0 home runs, we would expect them to score about 492 runs. Okay. So we've taken care of kind of all of this generalization about our data. One of the reasons it's important to do this, though, is because we want it to be able to use this to make predictions or to, test a theory. So I'm just going to take Milwaukee here, the Brewers, and I'm going to see how well our equation works with Milwaukee. So I'm going to type in equals, and I'm going to use my slope of 1.2823 times, and now I want to multiply that by my x value. My x value is home runs. Well, Milwaukee hit 224 home runs. I can either type in 224 or I can just click on that cell. So it says B17 now because that's where that cell is located, B17. So I have my slope times my x value. Now I want to add my y-intercept, which is 491.78. and 91.78. There's my equation. I just hit enter, and it tells me that according to our equation, we would expect the Milwaukee Brewers to have scored 779 runs approximately, and they actually only scored 732. So this prediction was a little bit high for the Milwaukee Brewers. What we could do is, if you notice when I hover over the bottom right of this cell here, the cursor changes. We can click that and we can drag it up, and we can drag it down as well. And now it's making that same prediction for all of these teams. So we can see how well it did with each team. And you can see that with some teams it's closer than others. For example, with Detroit, they scored 735 runs. Our prediction was 732. Others were further off. Houston, they scored 896 runs, and our prediction was 797. Okay. Again, this is a prediction. You can see that obviously all of the points don't lie on that line, but this is the line that best fits the data. And so this is the line that's going to give us our best approximation, just using home runs, for how many runs a team is going to score. Thank you.